In this video, we are going to learn a bit more about lists and have some fun with them. In the previous lectures, we had always started with a mantra from turtle import star. But that particular mantra was used because we wanted to use the turtle module to draw nice pictures for us. This time around, we are not going to draw any pictures. So, sorry for that. But you will see that even without pictures, things can be quite a lot of fun. Also, because we are not drawing any pictures, we don't need to invoke our customary mantra from turtle import star this time around. But we are going to have some fun with lists. And to begin with, let me just remind you what we already know about lists. Well, for that, let me just create a list for you. A list, you remember, is something which you write inside square brackets, and it will have several elements, one or more, or even perhaps zero if it's an empty list. And the elements could be of different types. Right now I'm writing a list with a 0th element, an integer, the 1th element, a floating point, a 2th element, maybe a string, a 3th element, maybe another list, and I could keep on adding more and more, but this will do for the time being. So this is an example of a list. Of course, it is not necessary that all the elements of a list be of different types, but what is important is that it can be of different types. Okay, and well, once we have a list, what can we do with it? We can find out how many elements it has using len. And notice that as far as the list is concerned, this 1 of course is one single element, 2.5 is also one element. The string apple isn't iterable in itself, it has many pieces, but it is one single element. And this list 2, this whole list here, is also one more element, which means there are 4 elements exactly in the list. And if I use the len function, which is a built-in function which you can always have access to, if you use that, you will get 4. Well, what else do we already know about lists? We can access elements from a list by just using square brackets and the index value. So li square bracket 0 is the 0th element. Counting starts at 0. So what we would usually call first element in according to English grammar, we actually call the 0th element here. So li square bracket 0 is 1, as you can see. And I can also actually change any one of the elements. Let's say li square bracket minus 2. Remember, negative indices count on the back. So li square bracket minus 2 means the second element from the end, the last but one element, in this case quote apple, the string. Well, I can change it to something else. Maybe I can even change it to a number, an integer. And now list becomes this. As we have already said before, a list is a mutable entity. What that means really is that once you have created it, you can also change it. Here I have changed the list li so that it now has elements 1, 2.5, 3 and a list 1, 2, 3. Okay. So we also know that we can take slices of lists, which is we can ask for something like 1:3. What that means is take element number 1, start there, add element number 2, and stop before you get to the stop value, which is 3. So element number 1 and element number 2 are the only elements that we are going to take here, and give me a new list made out of these. So 2.5 comma 3. 2.5 is the 1th element of li, this one here, and 3 of course is the 2th element. So this is how a slice works. I can also make the slice more, well, powerful by using 3 entries, the start value, the stop value and the increment. and these work very much like the arguments for the range function, which is one very nice way of creating list-like objects. Just to remind you, this is something we have been meeting almost every video so far. The function range takes up to 3 arguments, at least 1 and up to 3 arguments, and what it produces, say something like range 10, what it gives you is something slightly strange. It does not give you a list, at least not in Python 3. In Python 3, it gives you something called a range object, a class range object, which is a special kind of thing called an iterator. We will talk about that in some detail later. For the time being, let's just say if I wanted to quickly create a list with 10 elements, let's say li1, a new list, what I will do is use a range 10 function, but use it as an argument to another function called list, whose job it is to change whatever iterable it gets into a list. And li1 now is actually 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So by default, if you give only one argument, that's the stop value. Start value is 0 by default. It starts from 0, goes in steps of 1, that's the increment, which is 1 by default, and goes right up until it stops one short of the stop value. So it's not going to touch the stop value. That's what you have to remember. If you give 2 arguments to range, the first one is going to be taken as a start value, the second one is going to be taken as a stop value. So now you'll get elements 2, 3, 4, 5, 6, 7, 8, 9. Once again, 10 here is a stop. It means the thing stops before it gets to 10. And you could also have something like this: 2, 10, 2. 3 arguments. This means start, stop, increment. It starts at 2. Increment, which is the third argument, is 2 here again. So it will go like 2, 4, 6, 8. The next element would have been 10, but our rule is the list will never touch the stop, and so you will just get 2, 4, 6, and 8. So this is how you can quickly create lists with elements forming a pattern. This pattern is what is called an arithmetic progression in mathematics. You start somewhere and go up in equal steps until you reach some final destination. So that is one quick way to produce lists. What else do we know about lists so far? We know that once we create a list, we can actually make it longer by using the append function. So what does the append function do? Just to give you an idea of that, let's remind you that li, this is the list that we had, and if I said li.append, say 5, now notice this syntax very carefully. The rule by which this statement is written is something like this. This append is a function, well, we usually call it a method. It's a method which is tied to a list in this case. So in particular, this is a method which is tied to a particular instance of a list. A list is a general kind of object. It's a sort of abstract idea, a collection of elements one after the other. What we are looking at is a specific instance of that. There is this list li that we have, and this append is tied to that particular specific list. And what is it supposed to do? It's supposed to take that list and add whatever argument you have given to it as the last entry. Notice that this has changed the value of li. Li has become longer. So this append is a sort of doing function. It doesn't talk back to you. It does not give you back anything. It just silently goes and does its job. It changes the length of the list by adding its argument to the end. So if I tried something like 5,7, now I am getting an error. Notice the error here is append takes exactly one argument, 2 given. So if I wanted to add both 5 and 7 to li, I can't do it in one go using append. I could of course say li.append 5 first, then I could say li.append 7. Then 5 and 7 would both have been added. But you cannot use two distinct elements even if you want to add them like that. One solution of course could be this. Put 5 and 7 together in a list, and now that you have a single list, you use that as an argument to append. You can of course do that. But if you do that, what will happen is whatever single element you have given, that goes as the final element of the list. So instead of adding 5 and 7 to our list, which was, remember, already this, instead of adding 5 and 7 as two elements one after the other to our list, what this will do is just add the list 5,7 to li. So if you look at li, you get 1, 2.53, 1, 2, 3, 5, which was already there before, and the final element has become 5,7. We also learned that there is a method which is available for lists, which will do actually what we wanted to do, and that's not append, that's called extend. Now extend takes a single iterable as its argument. Just to remind you, an iterable is something which comes in pieces and breaks it up into pieces and puts the individual pieces after the existing list, thereby making it longer. So what does this do to li? Let's see. It exactly breaks up this 5,7 into two elements, 5 and 7 separately, and puts them one after the other. Extends the list. Just to make sure that we have understood this, extend can take any kind of iterable, doesn't have to be a list. So for example, if I put apple, the string, as an argument to extend here, what would happen is extend would break up apple into 5 distinct strings, characters apple, and add those 5 characters to the end of the list li. So let's take a look. So the list has grown by 5 elements in one go. It was up to here so far, but now you have apple added to it. So this is a recapitulation of all that we had learned about lists in the previous lectures. Today we are going to learn about how to do calculations, some very simple calculations using lists. And the first thing that comes to mind is something like this. Can I add, say, 1 square plus 2 square plus 3 square up to m square using a Python program? And well, as we will see, we can, of course, and there are several ways of doing it. One of them is, as I have discussed in the previous lecture, by using the idea of what is called a running sum. What is this? It's simply this. When somebody asks you to add 1, 2, 3, 4, 5, can you add them all in one go? Actually, you may think you can, but you can't. Addition is always done between two things at a time. It's what mathematicians call a binary operation. That may sound quite a mouthful, but it simply means you can add two things at a time. So What does it mean when we say we are going to add 1, 2, 3, 4 and 5? Well, what we are going to do really is we are going to start with a running sum. Well, before we add anything, this running sum is simply 0. Then we add 1 to it. 1, the first entry. Okay, so my running sum becomes 1. Now the next number that to be added comes in, that's 2. We add it to the running sum, it becomes 3. Then we get 3, the next entry. Add it to the running sum, which was already 3, remember, it becomes 6. Then I get 4, which is the next entry. Add it to 6, I get 10. Then I get 5, add it to the running sum, I get 15. And that is how we do the summation. So you start with a running sum of 0 and keep on adding the numbers as you get them. So here we can use this idea and use a simple for loop to add, let's say, the first 20 squares. So what we need first of all is a running sum. Let's call that r_s. Typing running sum is a bit of a bother. I'm just going to use r_s for the name. Remember, variable names can start with letters, can't start with numbers, and can only contain letters, numbers and a few special characters. Underscore happens to be one of them. So when you write r_s, you are just using the underscore to join the two parts of your name. R stands for running, S for sum. So we start with a running sum of 0 and then we add the squares of the first 10 integers. How do we do that? We run a loop. So remember, the way the for loop works is you have the for keyword, then you have a variable name. In this case, I've just used I in an iterable. So for variable in iterable, something which can give you things in pieces, and range, while not a list, is still an iterable. It produces one number at a time. And if I want to square 1 to 10, I need to take range 1, 11. Now this is important. You need to start at 1 and then keep on going up by 1 every time until you reach 10. And because you want to reach 10, your stop value for range has to be 11, not 10. And then of course you have to end this with a colon. So here every time the loop runs, I is going to get the value 1, 2, 3, 4 in succession right up to 10. So what do we do? What we do is every time the loop runs, I get I square that, which is I just take I double star 2, that's how you square I, and add it to whatever running sum I already have. So what does this really mean? It means that the right hand side is first worked out. That is, the interpreter will take the current value of r_s, add to it whatever you get by squaring I, and then push the whole thing into r_s. So our running sum changes because I square is being added to it every time. And once we go out of the loop and ask for the value of r_s, I get 385, which hopefully is 1 square plus 2 square up to 10 square. If you know the formula is n into n plus 1, so that's 11, into 2n plus 1, that's 21 by 6, that's 385.0, and we did get 385 a while ago. So this works fine. But can we do this using lists in some other way? Well, what we could do is first create a list which has 1 square, 2 square, 3 square, 4 square, up to 10 square. These numbers as elements. Once we have that, we can then use a function called the sum, which will just add up all the elements. Sum is a built-in function, it's already available for you, and if you give sum a list as an argument, it will just add up the elements of the list. That's it. Simple. So how do we first create this list with elements 1 square, 2 square, 3 square, up to 10 square? Well, one way would be start with an empty list, right? So this is an empty list, nothing in it, it's just an opening square bracket, ending square bracket. If you want to check whether this really is a list, let's find out. It does say list. Okay. But now what I'm going to do is I'm going to generate the squares of the natural numbers 1, 2, 3, one after the other, and keep on putting those squares that we get at the end of whatever list I have at the stage. For that, the append function, of course, will come in handy. So, once again, because I want 1, 2, 3, 4 up to 10, I need range 1, 11. But now what I do is I append to L, not Li, L is my list here, the number I square. So what happens? The first time around, just before it entered into the loop, L should be an empty list. Now, the first time the loop runs, I takes the value 1, I square is 1. 1 gets appended to the empty list, so L now becomes the list with only 1 in it, only one element, 1. So the loop runs again. Now I is 2, I square of course is 4, and that is appended to the list. Remember, append just changes the list as it stands, so it just keeps on adding more and more elements to it. So list now becomes 1, 4. And I keep on going until the end of the loop is reached when I takes the value 10. Okay, so what is the value of the list now? Should expect the list which started out as an empty list to become a list with entries 1, 4, 9, 16 and so on all the way up to 100, and that's exactly what has happened. And then of course I can just say sum L. So start with an empty list, keep on appending the elements as they come, and you have got the new list for you, and then you just sum it up. That works fine. Of course, the answer is the same as the one you got in the previous method. The previous method is more like the kind of method we would use in ordinary or other programming languages. Python, of course, allows you to do this. This way, using a list and appending elements to it to create the new list, and then using sum, a built-in function, is somehow more Pythonic, if you understand what that means. But is that the only way to do it? The answer is no. What you could do is, instead of saying append, I could try something like this. Let's start with the empty list again. And then again run the loop. But this time, instead of appending, let's try doing this. Well, L I minus 1. Why I minus 1? Because I goes from 1 to 11, but the indices of length of the list L should go from 0 to 10. So Li minus 1 equals I square. This should work, but actually it doesn't. And that's simply because what I said right now is wrong. It should work, it's not really correct. And it's very easy to see where the problem is. It's saying index error, list assignment index out of range. I'm trying to assign a value to the list, but I'm trying to assign a value to an index which doesn't even make sense for the list. Initially you have an empty list, it doesn't have anything, no index value. So when I try to put in L square bracket 0, It's complaining simply because it doesn't know what L square bracket 0 is. L doesn't have a 0th element. Every non-empty list has a 0th element, but this L doesn't because it has no elements in it. So what's the way out then? The way out could be something like this. I get these elements 1, 4, 9, 16 while the loop is running, but if I want to assign them to their proper positions in a list, I must first make sure that these elements are already there. Not the actual elements, but at least the positions where I want to put those elements. So since I'm going to get 10 elements here in the end, what I want to do is create some 10 element list. And one easy way to create a 10 element list, well, the hard way is just type square bracket and 0, 0, 0 and count carefully until you get 10 of them. But the easy way is start with a list which has only square bracket 0, only one element, and quote unquote multiply that by 10. When I say quote unquote multiply, you must realize that this makes no sense really, right? You cannot really multiply a list by something else. But actually it does make some kind of sense if you think about what addition of two lists mean. Suppose I had a list with elements 1, 2, 3 and another list with elements 11, 12. So let's say these lists were A and B and I tried A plus B. What will happen? Well, what will happen of course depends on how the action of plus is defined in Python. In this case, when plus is put between two lists, this action is defined simply as what is called concatenation. Again, a mouthful, but it really means put one list right after the other. So instead of a 3-element list 1, 2, 3 and a 2-element list 11, 12, what I will get is a 5-element list 1, 2, 3, 11, 12. So that's when you do a plus. Now, if that is what a plus is, what is multiplication? At least what is multiplication by an integer? We all learned this in school, elementary school. Multiplication by 5 really means adding 5 times. Similarly, multiplication by 10 would mean adding 10 times. Adding 10 A's together. That's what 10A is. For a list, it means doing the list plus the copy of the list plus another list plus another list, the same list in fact, as many times as you're multiplying. So square bracket 0 start 10 simply means square bracket 0 plus square bracket 0 plus square bracket 0 etc. 10 times, which simply means you repeat the list 10 times, the element 10 times. So L now is actually 0, 0, 0. If you count carefully, you will find that there are exactly 10 elements here. So now you have a 10 element list. So that does have an index 0, index 1, index 2, index 3 all the way up to index 9. And now this is going to work. Because the first time the loop runs I is 1, L square bracket 0, which was 0 to begin with. Initially every element of the list was 0, but now L square bracket 0 changes to 1 square. So L square bracket 0 becomes 1. The next time the loop runs, I is 2, L square bracket 1, this element which was 0 so far becomes 4, and so on. So this exactly gives me the same list as I got the last time, and I could just use sum on that. Well, so far we have seen 3 ways of summing up 1 square up to 10 square. One way, simply use the running sum concept. Don't store anything in a list. Just run a loop 10 times. Of course, you need an iterable for that, but we have the range function for exactly for that. And then every time a new number comes in, you just take its square, add that to the running sum. That's it. That's one way. The other way is first create a list with the elements that you want to add up and then use sum. Even the second and third way, both are that. The second way is start with an empty list. Keep on appending the elements as they come to create a bigger list. And the third way is start with a list which has exactly the right number of elements that you want at the end, and assign elements, assign values 1 square, 2 square, 3 square, etc. to these elements. And in the end, we end up with this 10 element list that we want, and we can use sum on that. Well, ultimately, what did we do? We created a 10 element list whose elements are squares of what range 1, 11 gave you. Now let me describe a final way of creating this list, which actually gives Python a huge amount of power. What is this way? This way is something like this. You start not with an empty list. I have things to type inside the square bracket here. When I type inside the square bracket, it's simply like this. And this cell is exactly the list that we wanted. So notice that there is a well-defined way of writing this thing. You have to write something inside a square bracket. And what am I writing? I'm giving a template here. I want to create a list whose elements are I square. What are i's? I's are taken from this for I in range 1, 11. This is what is called list comprehension. This is a very powerful thing which Python allows you to do, and as you will see later, this can be used in many very innovative ways to do a lot of calculation very fast. Notice that I did not have to write a for loop with a colon at the end and a body, header line and a body for this. Actually, I did write a for loop. This was an implicit for loop written entirely inside this. In fact, I could do the calculation without even storing this list in the variable L. I could have just done the whole calculation, which essentially is calculating the sum of this list this way. I could use a sum function whose argument has to be the list whose elements I need to sum up. I could create the list then and there. And lo and behold, in one line we have got the sum 385. I hope it is quite clear from what I have said about list comprehension. You do not need to do list comprehension only using the range function or the result of the range function. Any iterable can be used. So for example, what I have done right now is I have used x for x in apple, where apple is a string. So here also there is an implicit loop. I did not write the loop using a header line, a body and so on, but the job was done just the same. This is take the string apple, break it up into its constituent elements. That is the value of x at each stage, and take those x's together to build up the list. That is why what we ended up with is a list which has the individual strings with one character each: A, B, P, L, E. We can actually use list comprehension in much more varied ways. One of them is this. You can actually also put in conditions while building up the list using list comprehension. For example, going back to our example of this range 1, 11 thing that we used a while ago, let's try this. I will produce a list of cubes of the elements taken. So for I in range 1, 11, No surprises what this will give you. This will simply give you 1 cube, 2 cube, 3 cube, up to 10 cube. But I can actually add a condition. Say I can say if I square, let's say, is less than 50. What that means is the list comprehension will work to produce a list. It will take I out from the iterator range 1, 11. So I will take values 1, 2, 3, 4 up to 10. But it will produce a list with the values of I cube only as long as I square is less than 50. What that means is, of course, not all the i's will come in here. Only 1, 2, 3, 4, 5, 6 and 7 will, because 8 square is 64, that's more than 50. So in the original range you had 1, 2, 3 right up to 10, but here you will get 1 cube, 2 cube, 3 cube up to 7 cube. So let's just see that. 1 cube, 2 cube, 3 cube, 4 cube, 5 cube, 6 cube, 7 cube. Now I can combine these conditions with the with this list comprehension in clever ways to do many nice things. We are going to see more and more examples of this in later programs. We will see that many very complicated things can be done very neatly and quickly without ever writing down an explicit loop, just by using list comprehension. In a sense, list comprehension is a very Pythonic way of doing things. You don't really want to write down explicit loops which tell the computer, okay, take a loop variable, change it from this value to this value, and for each one of those do this in a body. You can do much of that stuff just by using list comprehension. Now, as a final example of list comprehension, before I go, let us try something like this. 1 plus, okay, not 1 by 1 square, which of course is 1, plus 1 by 2 square, plus 1 by 3 square, plus 1 by 4 square. If you keep on adding this up and actually calculate the infinite sum of these, this of course 1 square, 2 square, 3 square never ends, and the reciprocals get smaller and smaller, and if you keep on adding them up, you finally end up with a rather nice finite result. And if you actually could manage to add up all infinitely many of them, which you can't by the way, but there is a technical way in which you can define this infinite series sum, which those of you who are in high school may have already learned about. It so turns out that the value of this infinite series sum happens to be pi square by 6. So let us check that using Python, using list comprehension in Python and the sum function. Of course, one thing Python cannot do, no matter how powerful it is that it cannot add up an infinitely large number of elements. After all, that would have taken infinitely long time, which nobody has in their hands. But what we can do is we can actually use a very large number of elements, with the hope that because the terms 1 square, 1 by 1 square, 1 by 2 square, 1 by 3 square is becoming small very rapidly, if I use a very large number of initial terms, the ones which we drop will not make much of a difference. So how do I do this? Well, first I need to build a list with the 1 by 1 square, 1 by 2 square, 1 by 3 square, etc. up to some very large number. And once I've got the list, I need to sum it up. So I need to sum up the elements in this list. 1 by I square, 1 by 1 square, 1 by 2 square, 1 by 3 square, and so on. And let's say I want to add first 100,000 terms. So that's the range done. That actually is not really 100,000 terms, it's 99,999. But this will give me the sum of a very large number of terms of this series. And let's store this in a variable. Let's call that capital S, because we want to check whether this S is actually pi square by 6. So what does S work out to be? Notice that it hardly took any time to do this calculation. So this calculation, which is a rather non-trivial one, took us just one line of code, and it was calculated in almost no time at all. And this S works out with this number. Is this pi square by 6? Well, one way to check this would be to multiply this S by 6 and then take the result of that and find the square root. Now there is a nice mathematical function to calculate the square root in Python, but we have not learned that so far. But most of you do know that square root is nothing but a number raised to the power half. So we will just do that. And notice what I'm getting here is 3.141583104230963. Now I'm pretty sure most of you do not know this many digits of pi, but I'm pretty sure most of you do know that 3.1415 is okay. That's exactly what pi is, up to that many digits. So we see that we of course don't expect this S to be exactly equal to pi square by 6, because that's only the result of this infinite series sum. But by taking a huge enough number of elements of that, I've been able to get the result very, very well close. I've been able to get very, very close to the result. Let's see that. So in this particular lecture, I showed you how to use lists in many ways, how to create new larger lists from other lists by appending or by assigning values to elements, or, well, much better, the last method, list comprehension. We will come back to this and use these methods several times in the rest of our course. But for the time being, let's say goodbye for now.